Now that we have good practice on our power rule, we can add two more derivatives to our formula list. The first is that of sine. The derivative of sine is going to be cosine. If we were to approximate the derivative at every point and plot those derivatives, so graph the derivative like we had in a previous section, we would see that the derivative of sine follows all the properties of cosine. Similarly, we also have the derivative of cosine. The derivative of cosine is going to be negative sine. So we can add those to our formula list so that now we'll have 5. So let's do some practice problems now that we know the derivative of sine and cosine that include those. Example 9. For each of the following functions, compute the first and second derivatives. So let's start with 6 times cosine. So the constant multiple rule works for all derivatives we're going to be looking at. If you have a constant times a function, the derivative will always be that constant times the derivative of the function. So here, we said the derivative of cosine was negative sine. So we have 6 times negative sine, which is negative 6 sine x. The second derivative is going to be the derivative of negative 6 sine x. So that means we're going to have negative 6 times the derivative of sine. The derivative of sine is cosine. So again, the first derivative here is negative 6 sine x, and the second derivative is negative 6 cosine x. If we were to keep going, we would get another sine, another cosine, and then another sine, another cosine, because these are cyclical, and what would change is whether or not we had a positive or negative in front. Part B, sine x plus 1. So we said that the derivative of sine is cosine. So we start with that term. So we get cosine x. Now the derivative of 1 is 0 because it's a constant. So now the second derivative means we're taking the derivative of cosine, which from our chart is negative sine. So our first derivative is cosine of x, and our second derivative is negative sine x. Part C. We have x cubed minus 2 sine x. So our first derivative, we go term by term. We get 3x squared minus 2. Now derivative of sine is cosine. So minus 2 cosine x. And our second derivative, the derivative of 3x squared is 6x. And now the derivative of cosine is going to be negative sine. So the negative from the negative sign will cancel the negative in front of the 2. And we get plus 2 sine x. So the second derivative is 6x plus 2 sine x. So adding in sine and cosine, all of our formulas work the same way. It's just another set of derivatives that we're going to have to get used to using. Let's try a couple more examples with sines and cosines. Example 10. Find the equation of the tangent line to f of x equals 3 cosine x at pi over 2. So again, to find the equation of the tangent line, we're going to need to find the functional value at pi over 2 so that we have a point, and the derivative at pi over 2, which will give us the slope. So f of pi over 2 means we're plugging pi over 2 into our function. So 3 cosine of pi over 2. So cosine of pi over 2 is going to be 0. So that means 3 times 0, which is also 0, which means that our point here that we're working with is pi over 2, comma 0. Now the derivative at pi over 2 means we need to find the first derivative of this function so that we could plug in pi over 2. The derivative of cosine we said was negative sine. So we have negative 3 sine of x is our first derivative here. Notice that I'm consistently pulling the negative to the front whenever I end up with a negative part of my derivative. So now I need to plug in a pi over 2. So negative 3 sine of pi over 2. So sine of pi over 2 is going to be 1. And so negative 3 times 1 is going to give me negative 3. And remember, that's the slope of my tangent line. So using y equals mx plus b, I have y equals negative 3x plus b. Now to solve for b, I'm going to plug in my point. I'm going to plug in a 0 for y and a pi over 2 for x. So here, I'm going to add this term over to the right, and that will tell me that b equals 3 pi over 2. Therefore, the equation of my line is y equals negative 3x plus 3 pi over 2. Now remember, this is the same thing as 3 halves times pi or 3 times pi over 2. So we can write this a lot of different ways that mean the same thing, but the convention is to combine the terms in the numerator to make it more simplified. Let's try one final example. Example 11. Consider the function f of x equals cosine x minus x cubed. Calculate the following quantities and round to 3 decimals. So here we're going to start with f of 2. That means we're taking 2 and we're plugging it into the original function. So here when we plug in 2, we're going to get cosine of 2 minus 2 cubed, which is 8. So cosine of 2 minus 8. If we were looking for an exact answer, that's how we would enter it. So if on your homework you're asked for an exact answer, enter it as cosine of 2 minus 8. However, in this problem, we want to round to 3 decimals. So we're going to plug this into our calculator, making sure it's in radians, and we're going to get negative 8.416. Next, we want to find the derivative at 2, which means that we first need to find the derivative function so that we can plug in a 2. The derivative of cosine, we said, was negative sine x minus, and the derivative of x cubed is 3x squared. So we want to plug a 2 into that function. So negative sine of 2 minus, if you plug in a 2 into 3x squared, you get 2 squared, which is 4, times 3 is 12. So again, if we were looking for an exact answer, we would enter it as negative sine of 2 minus 12. That's exact. It's not rounded in any way. But for this problem, we want to crunch that number to 3 decimals. So we're going to carefully enter that in our calculator, again in radian mode, and we're going to get negative 12.909. And then for part C, we're looking for the second derivative at 2. So first we need to compute the second derivative. So we go back to the first derivative and we take the derivative of that. The derivative of negative sine is going to give me negative cosine because there's a negative 1 in front that's multiplying, minus the derivative of 3x squared, which is going to be 6x. So now when we plug in a 2, we get negative cosine of 2 minus 12. So again, if we wanted an exact answer, it would be negative cosine of 2 minus 12. But since we want 3 decimals, we crunch that number and we get negative 11.584. So quickly, let's remember what these numbers are going to tell us. So here, this negative 8.416, that's going to tell us that the function is negative at x equals 2, which means it's below the x-axis. Because the derivative is negative, that tells us the function was decreasing at 2. Because again, if your function is decreasing, your first derivative is negative. And then finally, because the second derivative is negative, we know that the function was concave down at 2. So we have a negative value that's decreasing and concave down is what's happening at x equals 2. And all of that information we get by looking at the various values of the function, the first derivative, and the second derivative.